Hi all, welcome back to another lecture of DBMS, and in this lecture we'll be learning joins. So joins basically we use to merge smaller tables basically to perform some denormalization to return the queries which user wants. So basically we'll be learning about what are joins and what are different types of joins. So basically merging the tables in different styles can be the inner join, left join, right join and outer join. So stay tuned for the video and trust me, this video is again going to be very much interesting and important from the interview perspective as well. So let's begin with the first topic, which is what are joins in SQL. So joins are used to combine rows from two or more tables based on related columns between those tables. So let's suppose we have table with column A, C and D and another table with column A, B and E. So we can join these two tables on this common column, right? So this is what it says. On related column, we can merge two tables and with the relations between them. So it allows retrieval of data spread across multiple tables. So as we have, let's suppose A, B, C and D, E, F, D, A, D, E, okay? So we can join these two tables. Why? Because what if we want A, C and E, okay? So we'll join these two tables and we'll fetch that A, C from this table and E column from this table. So basically it allows retrieval of data which are already spread on multiple tables, and it enables more complex and meaningful queries as well. So a join operation compares each row from one table with every row from another table. So basically when we have, let's suppose A, B and C, okay, and we have another table too with C, D and E. So what it will do, it will first row will be compared with C. So A will be compared with C, A will be compared with D, A will be compared with E. On the basis of condition, if it is true, it will, keep the data. Otherwise, it will just iterate, but it will check. Then again, B will iterate, B will be compared with C, B will be compared with D and B will be compared with E. So similarly, every row from one table will be compared with every row to the another table. So 3 rows into 3, so total number of joins will be 9. So this actually makes more complex. But a join compares each row from one table with every row from another table to find pairs rows that satisfy the join condition. So basically we are finding the pairs and to check and to satisfy the condition of the SQL query on which we want to fetch the data. Complexity of joins. So basically in the worst case, let's suppose we don't find the, if we are going to find the relation according to the condition at the very last. Very last means A, B, C, we have 3 rows in one table and D, E, F. And let's suppose we want C and F, okay? So we'll compare A, D, no, A, E, no, A, F, no, B, D, no, B, E, no, B, F, no, C, D, no, C, E, no, C, F, yes. So this is the worst case, and here we did 3 cross 3, basically n square nested loop join is required. But in case of hash table, where we basically use the index to find out that thing, and indexing actually reduces the time complexity of fetching data. And next, the merge join. So in both the cases, the time complexity will be n plus n. And here the matching rows, they progress through the sorted data. So in the merge, basically the data will be sorted and then we will be applying that join condition. But in hash table, we will be using indexing to find out. So these are the different complexities of joins based on the different conditions. Now let's start the different types of joins in the SQL. So basically we use join, and it allows the SQL users to work with data spread across multiple tables in relational database, right? And it also, these joins are very much important for creating meaningful reports, answering business questions, maintaining data integrity. So first type of join is inner join, left join, right join and outer join. So we'll be learning about all these joins one by one, but as of now, let's try to understand with the basic thing that inner join results only those rows which actually matches between the two tables. So let's suppose we have two tables and 1, 2, 3, 2. So only if 2 and 2 are matching, so inner join will result 2 as an output. So the number of matching rows, inner will result. Next is left join. So let's suppose in one table we have 1, 2, 3 and in right table we have 1, 2 and 4. Okay. So left join says all the rows from left plus the rows which are matching from right will be considered. Similarly, for right join, all the rows from right table and the matching rows in the left table which are already in right table will be the answer. So 1, 2. So for left, 1, 2 and 3, because 1, 2 are already matching and 3 is present in the left table. For right, what will happen? 1, 2 matching and 4 because it is present in the right table. This is what it says. And in case of outer join, basically it gives the result, the results from both left join and right join. So it gives the result, whatever the result of left join and whatever the result of right join. So 1, 2, 3 was the result of left join and 1, 2, 4 was the result of right join, right? So for the outer will be 1, 2 and 3 and 4. So this is what it gives, right? Now let's try to learn each and every join one by one. So first is inner join. So it results only those rows where the data, like the rows are matching in the both table. So let's suppose we have train table and booking table, and here we want to apply the inner join. So let's see how we are writing the SQL query for it. So we'll be first writing select trains.train, because we have two tables. So we'll be writing train.train ID. Why we are writing so? Because train ID is the attribute which is common in both the tables. So to specify it, we'll be writing it with tables name dot train ID, then bookings dot train ID. So we'll be selecting trains dot train ID, trains dot train name, okay, and bookings dot passenger name. So we'll be selecting train card, train tables, train ID and train name. And from booking table, we are selecting the passenger name. From trains, and it is the inner join. So we'll be writing both the table names. So from train, inner join, bookings. So train table and booking table we have written with the inner join in between. On means now we'll be writing the condition on what we want the join. So join will be on trains.train ID and bookings.booking train ID. Why we are saying this? This is what we already meant, that when we want to join two tables, we want at least one unique column to be same in the both tables, then only the relation can be found. So here we have train ID and train ID in both the tables which are common, and on this attribute only we are going to apply the relation to find out the joins. So how we have written on train.train ID equal to bookings.train ID. So we are going to select only those train ID, train name and passenger name from these two tables, applying the inner join where train ID in both the tables are exactly same. So let's see, in this 101 is already there, yes. 102 is already there, no. 103 there, yes. 104, no. So what inner join says, the number of same matching rows will be the resultant. So here 101 and 103 are matching, right? So inner join will result in 101 from this table, okay, Rajdhani Raj, okay, done. Now 101 from this table, which is 101 from this one, right? So Raj matching, yes. Now another 101 also. Why? Because these both are matching in both the tables. So 101 will be 2 times. Now 102 is not there, so 103 will be there. So instead of 102, we'll write 103. Train name for 103 is Duranto. So we'll be writing Duranto and name will be Lisa. Okay, so this is how it will look like, 103, 101 and 101. So this will be the output for the inner join. Now let's see left join. So left join says that we'll be returning only those rows from the left table and matching rows from the right table. So we'll be sending on returning all the rows, like right, all the rows from the left table and the matching rows from the right table. So here we will be writing the query like select train.train ID, okay, train.train name, okay, and booking.passenger name, okay. So we want these 3 attributes to be selected as an attribute for the final resultant table. We are applying the left join on 2 tables. So we'll be naming it trains and bookings, okay. On, what was the condition for join? Trains.train ID should be equal to bookings.train ID. So again the same condition, just the only change, instead of inner join we'll be writing left join. And now let's see, if you are just changing the different type of join, how the resultant query will resultant table will vary. So left join says all the rows from the left will be there. So, okay, 101 from this from this will be there from the trains table, yes. And 101 from the bookings table, because it is matching, so yes. So 101 will be 2 times. Now 102 is there in left table, yes. It's not there in right table, but as it is left join, so it needs to select the left table rows. So 102 will also be there. Okay. Now 103 is there in left table, 103 is there in right table. So it will give you the value. So it will give you the 1 value because it is matching. So 103 will be writing. Okay. Now 104 is not there in the bookings table, but as it is a left join, so it needs to select all the rows from the left. So 104 will also be considered as the last row here. So this is what the resultant table for the left join will look like. So in the query, you just change from inner join to left join, and this is how the resultant table will change. Now next is right join. It is similar to left join, but in this you are only considering the matching rows in both the tables plus all the left rows, like left means leftover, right? So all the rows from right table. So matching rows plus right rows. In left join, matching rows plus left rows. So let's see again. Instead of right, we have a left, we have only changed to right join, and all the queries are same. So in this, we are basically focusing on the right one, right? So what we will be doing? We will 101 are common matching. Okay, so 101 will be there and 101 will be this from the for Raj and Gauri, because we have to take it both from the left from the right table, so we'll take it right. Now 103 are matching, yes, so you will do that. Now 105, okay, 105 is not there. Now we have to take 105 also. So okay, 105 Shaurya, because it is right join, so it will take all the all the rows here. Now as you can see, 104 is not there, so you will not be taking it. Now train ID will be 105, and for 105 the train name is okay. Now you can see here for train 105, as per the rule you have to take it in your right join, okay. But for right join, for train ID 105, you need train name and passenger. So passenger you will get it from here. So Shaurya, you will get it from here. Train ID you have 105, okay. But train name you need to find in trains table. But in trains table, train ID 105 is not there, right? So train name for that will be null. So this is why we have written as null. So this is how the output of the right join will look like. Now last, which is outer join. So basically it is a resultant of both left join plus right join. So it gives it returns all records when there is a match in either table. It combines the result of both left and right join, and if there is no match in one of the table, null is returned. Let's see how. So 101, okay, so as it is a resultant of both left and right, so obviously left values and right values will be there, and duplicate value will only be considered as 1, right? So 101 is there in left, right, okay. 101 is there in right but not 1, but as it is in right, so we'll be considering it because it is a resultant of left plus right, okay. 102 is there in left, not in right, but we will select it, okay. 103 is there in both cases, okay. Now 104 is there. We can find the name passenger from name from here. Now we can find the 104 name like train ID and train name, okay. So 104 train ID and train name will be there. But as the 104 is not in the right table, so we cannot find the passenger name here. So for that, we will give the null value. Now for 105, as it is there in the bookings right table, so we'll write 105 and name. But train name, we need to find from left table. As the train ID 105 itself is not there in left table, so train name is also not there. So we'll be considering the value as null. So this is how the resultant for outer join will look like, because this is basically the resultant for both left join plus right join, and we will be keeping the value as null if we do not have that particular attributes name present there. So this was all about the 4 different types of join which we have learned in this lecture. Why we have learned joins? Basically to when we find and to merge, when we find data which are already present in different multiple tables. So to find those attributes or those datas, which are not present in a single table, we need to merge those tables, and we merge these tables with the help of these different types of joins, and we are apply these different types of join on the basis of our need and requirement. Like whether we want to emphasize on the left data, then we'll go for left join. Then otherwise, if we want some right data to be present and the matching also, so then we'll be going on the right join. And this is how, based on different conditions, we are going to apply different types of join. So I hope you understood and learned all different types of join in this lecture. That was all about the whole lecture. Now let's meet in another lecture. Till then, keep learning. Take care of yourself and your family too.